So lately we've been talking about using the analytical method to determine limits. And so one of the things that I need to mention real quickly is something called indeterminate forms. So indeterminate forms occur when it's some kind of direct substitution that we've essentially plugged in, and we get something weird where we're not exactly sure what's happening. I'll give you an example very quickly of something that's an indeterminate form. An indeterminate form would be if I plugged in and I got 0 divided by 0. Most people know right off the top of their head, you can't really divide by 0. It doesn't make a whole lot of sense. But especially in this case, 0 divided by 0. It really does not make sense to have 0 things and to try to cut it into 0 pieces. It's just even more confusing than just dividing by 0. And so when this happens, we're going to talk about some methods in a minute of ways of fixing this so that we can actually determine the limit. Another example would be is if you plugged in and got something like infinity divided by infinity. And I know most people are going to think, well, it's something divided by itself, it's probably going to be 1. Well, that's all well and true if you're talking about numbers, but again, infinity is not a number. And so you can't really just apply the same rules that you always would to anything else. And so, like I said, infinity is not a number. There are several times where I've talked about where I can think of that infinity is bigger than another infinity. And so in this case, again, it's not really something that we can talk about. It's not a number, so we can't perform a normal operation with it. And speaking of can't perform normal operations with infinity, other ones that we'll see that happen sometimes are 0 times infinity or infinity minus infinity. Even 0 to the 0 is still an indeterminate form because, again, 0 to any power is 0, and anything to the 0 power is 1, and so we're kind of in a bit of a contradiction area there. Another one would be 1 to the infinity. Again, 1 to any power is 1, but again, infinity is not a number. So it really just doesn't apply to the same rules. And the last one I'll say is infinity to the power of 0. Again, anything to the power of 0 is 1, but the problem is infinity is not a number. So it really just makes it more difficult when you're talking about things that aren't numbers. Now, one that is a determinate form, one that I can actually calculate real quickly and just express myself nicely, is, and even though it's not a number, I'll mention to you, is I can actually do infinity plus infinity. It's still going to be positive infinity. Even though those are concepts, they're not actually numbers. I can do addition here because if you add 2 really big positive numbers, you're still going to get a really big positive number. But like I said, if you try to subtraction does not make sense simply because we don't know. One of them could be bigger than the other. Is it going to be a positive number? Is it going to be a negative number? I really just don't know. Are they the same size infinities? We really just don't know. So in this case, there is no, it's an indeterminate form, but that green one, infinity plus infinity, is a determinate form. We do know it still makes positive infinity. I hope this kind of clears up the justification for why we're getting ready to go into talking about some new techniques. The techniques I'm going to show you next are the dividing out technique, the conjugate technique, reciprocal techniques, and some stuff to do with trig functions. So that'll help us with some of these indeterminate forms in just